Hello, Krasimir here, and this time I'll talk about splines. How to create splines from particles, how to mesh them, and at the end some Arnold splines rendering tips and tricks. On this path I'll also show you some other nodes and try to explain you how to use the node-based workflows, and you'll see how node-based workflow is really flexible and allows you about everything you want it to do. So let's create the FumeFX nodeworks. You can create it anywhere in the scene, it doesn't matter. And we have this female model that we're going to use to create splines on its surface. So for a start, we're going to create some particle generator that generates particles on the surface. And we're going to pick this plane below. This is just ordinary plane and is going to be used to spawn the particles. Initially there will be 100 particles created just on the first simulation frame, and that's enough for us. We can change the particles color, let's see, so we can see them on against the white model. Something like this will work, and we're going to slow them down a little bit to something like 2, so they have time to follow the surface properly. Remember that these generator nodes output particles only that are created. So since we create particles only on the first frame, all 100 particles will be output here for the first frame only. We need, however, particles on each frame of the simulation, as for each frame we're going to reposition those particles on the surface of this model. So we need another node, so right click, and here is a quick access to create group 1 node that output group 1 particles for each frame. And for those particles we're going to create follow surface node that will keep particles stuck on the model surface. And as you can see, particles will follow surface immediately. You can see that right now it's not very fast, but we can disable animated mesh checkbox here. This checkbox is served for the purpose that if your mesh is changing in any kind, you can enable this mesh and particle will update and follow animated mesh. This is static mesh, so if we disable this checkbox, particles will move in real time. Let's add some splines. We'll just need group 1, and we're going to create particle to spline node. We'll change the color. Okay, so we can see those splines better. And here is what we've accomplished so far. So for the follow surface, we have several options on disposal. The first one is affect velocities. If this is unchecked, then initial particle velocities will keep for the remaining time of the animation. So if we bend this plane, it won't matter, as particles will be always emitted in the z direction that's controllable from the source. So for example, if we can just add some variation in the emission, those particles, as you can see, will try to follow mesh along their initial velocity. follow surface also has ability to follow the surface along the face normals or vertex normals. Friction will slow down particles as they travel along the surface, and eventually they will stop. You can also follow not exactly on the object distance, but at some distance from the surface. We will come to the UV map channel later in this tutorial. So those are splines, and we want to add some mesh. That's spline to shape, and we can add some shape to some skinning, so to say, to the splines. So these are pretty big radius of the spline, and we can affect this by changing the spline knot radius. Each knot can have its own radius, and we'll get back to that a bit later. So this is something we need to maybe increase this velocity to 3, so we'll cover up a bit more of the model surface. We can, of course, for the spline to shape, there are several parameters, and we can use custom shape. So you can, for example, create let's create some star shape here, and we get back to the nodeworks, and we're going to use custom, and we pick the star shape, and we're going to scale this radius down a little bit more, and we don't want smooth sides. So you see, you can use whatever shape you want, and you can also add some twist along the path. Let's decrease particles maybe to 4 or 5 to see what we're doing here. Yeah. So, for example, what will turn back this to the simple? And now, for example, what if you want to have different radius of the spline on user controlled places? Well, that can be achieved quite easily. So we're going to disable nodeworks for a moment, go to this female head, and we're going to assign some vertex paint. So initially we're going to paint this model in gray. Yes, that's okay. And we're going to paint with white. So white areas will be those areas where radius will increase. Let's make it like this, around eyes, for example. Okay, now we can enable back our nodeworks and do some tweakings here. So as you can see, follow surface already has some UVV and position coordinates. There's a position on the object and UV coordinates that we're gonna use for the text map node. It automatically connects UV coordinates, and we're going to use vertex color text map to retrieve vertex colors from the mesh that we have painted before. Since text map is set to the vertex color, we'll need follow surface to return us the UV coordinates of the UV map channel 0, which is vertex color. And for the text map intensity, we want it to set to the particle attribute, specifically to the particle scale. If you hold Alt key, okay, let's just go back to frame 0, and we hold Alt key and drag, we will connect this to the scale pin node. You can notice that set attribute, you don't need to connect this pin, it's, let's say, virtually connected to this group, and this is just a tiny visual, so you see that everything's connected properly. So now we have set particle scale based on the vertex color map. And I can see nothing still happens. So why is that? Because this is the particle radius that we have to connect to the particle to spline knot radius. So we just connect scale to the knot radius, and now we can instantly see that this works much better now. We'll just need to add some tweaks here. We need smooth sides. So let's say we have to limit this knot radius not to go over some value. We want the scale, let's say, go from 0.3 to 0.1. Then we set here clamp, and let's say output pin type change to float, and let's say it's going to go from 0.1 to 0.1 to max of 0.3, and we'll reconnect this to the node radius. Yeah, so yeah, now that's more subtle change. We can reduce this, and maybe go to the X. Yeah, that's about nodes used for this setup. And now about the rendering part. So you can render this as a mesh in Arnold. I'm going to hide this female head, and to render Arnold curves we're going to need Arnold curves node, of course. So Arnold curves is procedural rendering of the spline, and we'll just need to match. We have the radius scale 0.1, and we're going to use radius scale of 0.1. So when rendering as a simple spline, the results identical. However, with the spline as a mesh, you get the smoothness by selecting the number of sides on those curves. However, if we, let's say, if we zoom in onto splines with Arnold curves, you'll always get smooth splines no matter where you are, where your camera is. Now the caching magic let's just get access. Let's go to the base frames, calculate all the time, so we're just going to get some caching here, splice, and we don't need anything of this, so we can disable. We just need splines here. We can now hit the export button and export basically just the particles with ID and splines. We'll have to stick in interactive mode, as cache mode won't process absolutely any node. So interactive mode will work with the Arnold curves, so cache mode won't. So we need to create another tab and add the load cache node. And we need to load our caches here. And actually, I'm going just to copy this node. We need to connect loaded splines to Arnold curves. And of course, we need to change to the interactive mode, so the simulation tabs are executed. Nothing will render past frame 100, so we need to change end frame for the load particle cache node operator. So now all the frames are loading, and we can open Arnold render view to see the result for the Arnold curves node. Whatever you change for the Arnold curves is really fast, because it only requires scene translation to Arnold renderer, and the update is a lot faster than if you would have geometry that would need to be recreated each time you change any scaling parameter. Thank you for watching this tutorial, and don't forget to subscribe to our channel for more video tutorials on FumeFX.